Hello friends. Today we are going to see that how we can convert a decimal number to binary number and how negative numbers are represented in the memory, how they are stored in many programming language. Here you can see that I have already written some number here. So our aim or objective is actually we can take any number. Suppose I am taking a number suppose 67. So we have to convert this number into the binary, and when you convert this number to the binary, then it is some representation in the form of 0 1. So your number can be like 0011 or anything. So this is the main thing, that how we can convert any number that is in decimal and given in we have to convert that in the binary. So I think you already know that these two number system, decimal and binary. For decimal number system, our base, actually in every number system there is a value base that we call the base. So base in decimal number is 10 and base in binary number is 2. So uh, this is the things we are going to see, that how we can convert a decimal number to the binary number. So here on the screen you can see that I already written some number. These numbers are actually, when you are want to convert a decimal number into the binary, then you have to represent your number only in these sum of these numbers. You have to express the numbers in this format only. So here what actually I write here 1 that is the 2 to the power 0, after 2 that is the double of 1, then 4, after then 8, then 16, 16 cut double 32, then 64. After that, I write here 128, and after that, I write here 256. So you can write one more number after 256, it becomes 512, 512 number. So that number actually we have to when you are going to represent, so you want these digits, that which digit is 0, which digit is 1. So actually with the help of these, we are going to convert our number into the decimal to binary. So there are many method, but this simple easy method I am explaining here. So suppose we are taking a number, for simplicity I am taking a simple number 67. So our question is that convert this 67 number into the binary. So what you have to do, it is very easy method, that first you must have this sequence. After that, you have to write the 67 sum of only these numbers, but you have to start somewhere with maximum number. So you can see that this 67 comes between 128 and 64. So you can say that 64, actually first I am taking 64. So 67 actually equal to 64 plus, then in 64, if you add 32, it becomes more than 67. In 64, if you add 16, 8 or 8, it becomes more than 67. So in 64, first I am adding 2. 64 plus 2, it becomes 67. And after that, I am adding 1. So actually, I represent the 67 number in the sum of any of these digits, but we have to start with the maximum. So you can say that 67 can be 64 plus 2 plus 1. After that, where the digit, actually you have to start with 64. So if 64 number is there, then you have to make that 1. After that, 32 is not there, so that we have to write 0. 16 is not there, 0. 8 is not there, 0. 4 is not there, 0. 2 is there, so it also 1, and 1 is there, it also 1. So I can say that this 67 binary representation can be 1, 0, 0, 0, 0, 4 times 0, and 1, 1. So actually this is the number, that is the 67. In the same way, suppose I want to convert the 100. This is another example. I want to convert the 100 into the binary. So in that case, we have to represent the 100 in the sum of any of these numbers. So for that, what I'm doing, 100 is come somewhere between 128 and 64. So actually, if I take 128, it is going to be more than 100. I am taking only 64. So 100 represented by 64 plus. After that, uh, if you add like 32, then 64 becomes plus 32. Again, it becomes I think 64 plus 32. So you have to add them 64 plus and 32. So 64 and 32 becomes 96. And in 96 we have to add one more number, that is 4. We have to start with this. So 64 I am representing like this. 100 I am representing like this. 64 plus 32 and plus 4. 64 plus 32. It is not 31, it is 32. 64 plus 32 plus 4. So I think that is correct. I am taking 64 plus 32. Um, it becomes 6, 4 and 2, 8, 4 and 2, 6, 6 and 3, 9, 96 plus 4, 96 plus 400. So actually with the help of this, you can say that at this digit, this 64 with here, with 64 it comes 1. After that with 32 it comes 1. After that 16 it is 0, 8 it is 0, 4 it is 1, and then 0 and then 0. So if you write this number representation, then this number is actually 1100 100. So here we can see. I think we can check this with the help of calculator. We can start the calculator. There is a programming calculator, and in this I can represent this number. So suppose I am writing here 100, and this 100, if I check in the binary, that is 1100 100. Yeah, that's correct. So any number you have to take, first you have to express that number as the sum of these numbers, but it is also important that you have to start with the maximum number. If you add anything, if you go beyond that number, don't add that number, go to the next number. So in this side, from the left hand side, you have to invert that. So in this way, you can check that how these numbers are converted into the binary. There are other method. This is one of the method or easiest method we can say. Okay, now there is a question. Actually, for that, I am going to run some program that how um, when you perform the bitwise operators on on the numbers, then how these bits are changed. So here you can see this next topic, that is the negative number representation. So for negative number representation, actually, when you are saying that you want to store this, suppose we are converting one more number 10. I want to convert this 10 into the binary. So 10 you can express like this. 10 is equal to 8 plus 2. So you can say that 8 plus 2, that is 10. So if you convert that into the binary, you can write that it is 8 becomes this 8 becomes 1, then this 0, then this 1, and again 0. So this 10 is actually 10 is, when you convert the pen to the binary, it is 1010. This is the number. So we can represent any number. I am taking this number 10. So my question is that, my point is that when this 10, actually I am saying plus 10, when this plus 10 is stored in your RAM, in your memory, in the bytes. So suppose we are thinking that it is taking 4 byte, integer. When it integer is stored, it is taking 4 byte. Uh, or I am saying that suppose it is stored in uh, sort integer, it is stored in 2 bytes. So for 2 bytes, I am taking that, suppose there are 16 bits are there. So 1, 2, 3, 4, 5, 6, 7, 8. After that again 1, 2, 3, 4, 5, 6, 7, 8. So we have to see that these 8 bits, what are these 8 bits? So I am writing that number actually 0, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. These are the 8, but I am taking last 4 1, 1, 2, 3, 4. It is 1010. So actually, whatever the number you are seeing here in the screen, this number is actually, um, here I can write plus 10. Actually, this is the number 10. Here I can show you. Okay. So 10 is actually, plus 10 is actually represented in this. So when you are representing your numbers, negative numbers, there is a problem that you cannot simply make it 1. If you are simply making it 1 and you are saying it is minus 10, it is going to create the problem of like if you write, suppose you want to represent the 0, all these bits are 0. And if you write this 0, it becomes plus 0. If you write this 1, it becomes minus 0. So there cannot be the concept of plus 0 and minus 0. That's why negative number. Actually, what we are going to do now, minus 10. How minus 10 represent in the memory? So minus 10 represent in the memory by using 2's complement. So if you, actually this is a new concept, I am going to tell you something about that. We are going to discuss about uh, 2's complement. 2's complement. So 2's complement, negative numbers are stored in the 2's complement. So what you to store, suppose minus 10 you want to store, what you have to do, you have to simply take plus 10, convert that into the 2's complement, and whatever the number, that is actually your negative number, negative 10. So how it is going to work, that first you have to take your number. Suppose I am taking this number. This is our number. Here I am going to write that. This one is our number. Uh, First you have to take the ones complement of this. Ones complement. Here I can write ones, ones complement. Ones complement. So when I'm saying that take any binary number, ones complement, take the ones complement of any binary number. So if you are taking the ones complement of any binary number, it is very simple method that you have to convert every bit. So these becomes 1, 2, 3, 4, 5, 6, 7, 8. All digits becomes 1, 1, 1, 1, 1. It becomes 0, it becomes 1, it becomes 0, and it becomes 1. So you can think that this, whatever the things I write here, whatever the things I write here, that is the ones complement. Now I am going to write, make the twos complement of the same number. So twos complement, twos complement of the same number. Actually, you have to simply add one in the ones complement. This is your ones complement. So in this ones complement, simply add one. You have to add one in this number, like plus one. If you add one more number in this, so actually you can think like this. अब इसको ऐसे समझिए, like I am adding here one, just I am writing here, typing here one. So this one is actually adding in this one in the binary format. So when you are converting that, this one and one becomes this one and one becomes 0, and that one comes here, and after that there is no change. So it is actually 1 1 1. After that 1 1 1 1 and 0 1 1 0. So this 1 and 1 0, 1 carry that comes here, 1 is same, this is same, this is same, all these things. So these are this is the 2's complement. This is the 2's complement. So when I'm saying 2's complement, this one, so actually this number is actually your negative 10. When you are writing negative 10, so negative 10 is written like this: 1, 2, 3, 4, 5, 6, 7, 8. After that, 1, 2, 3, 4, 0, 1, 1, 0. So actually, this is the number that how minus 10 is represented. To represent any negative number, to represent any negative number, first you have to write the positive number, that how positive is represented, and after that take the 2's complement of that number, and whatever the number it comes, it is the your minus 10. So now you can see that minus 10 is written like this. Okay, so there is a question comes in programming bitwise operator. So there is a bitwise operator, that operator we calls ones complement. This is the symbol, this one. When you have any integer and you put that symbol with this is unary operator. So it will convert your every digit. So suppose some number is given to you. Suppose we give you the plus 10 and convert the every bit. 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0, like that. Then we have to identify that what is actually that number. So with the help of this example, I am going to show you here. I can write in program, and with that you can understand that. So I'm taking a short integer, and that integer value is suppose 10. I'm for simplicity I'm taking 10. Okay, sorry, a is equal to 10. Okay, after that I'm taking one more integer, short integer b, another integer, and then I'm writing b is equal to 1's complement of a. So whatever the complement, 1's complement, that means with the help of this operator, every bit is changed. So you have to think that what is the 10, how 10 is represented in the memory. Actually, I can take from here, no issue. So this is the number we can take, and I'm writing here. You can see that 10 is actually, and this is your number 10. Okay. Now what is B? The question is what is the answer B? If I try to print the value of B, printf percentage D B. So we are trying to find that what is the answer. So what you have to think that when what is your B actually? Your B is actually simply because of this, every bit is change. Every bit is change. So it becomes 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. After that, 1, 2, 3, 4, 0, 1, 0, 1. This is your number. So one thing I can say that if you see this number is actually, this number is same as this number, then your answer is minus 10. But you can see the last digit is 0 here, and here our last digit is 1. Okay, so the point is that we have to identify what is actually this number. So one thing you can see that the first digit is 1. So in this case, we can say that it is a positive number. It is a negative number. So if this is negative number, so it is the number. This is 2's complement of some number. It is the 2's complement of some number, and जिसका भी ये 2's complement है, the number whose complement is this, that is your answer. Okay. S- So there is a reverse method we have to identify. Like I say that whenever you have some negative number like minus 10, convert that into the 2's complement. So this is your answer. Okay. Now there is a reverse question. That question is that we give you a binary number. This is the binary number. And you have to convert that into the decimal. But because this is a binary number, so it is represented in 2's complement. And if you want to find, this is the only thing to understand, that if you want to find that what is what is the number whose complement is this number. So to that, this is the simple process, that again take the 2's complement of this number and you will get the original number. Okay, I think you get my point. I am saying that if suppose you have a binary number in which the first digit is 1 and you think that it is a negative number, and um, it is the it is represented in 2's complement. So you want to find that what is actually this number. So what you can do, just take the 2's complement of this again. But I'm saying that suppose you have this number, you want to find what is that number, take the 2's complement of this number again. So if you want to take the 2's complement of this number, it is very easy. Simply write here 0, 0, 0, 0, 0, and 0, 0, 0, 0, 1, 0, 1, 1, and add one more in this. Actually when you add one more in this, जब आप इसमें एक को और ऐड करेंगे, then it becomes what I'm trying to say, add plus 1. So in that case your final number is actually जो आंसर आएगा आपका, that is 0, 0, 0, 0, 0, after that 0, 0, 0, 1, and that one, this becomes 0, this becomes 0, and this becomes 1. So actually 1, 0, 0. So this is the number. So if you know, this is now reverse thing, that how you can say what is actually this number. So to identify this number, in this 1 to third digit and fourth digit is 1. So with the help of this 0, 1, 2, 3, 8, it is 8 and 4, 12. So this number is actually plus 12. This number is actually plus 12. So this number is plus 12. The 2's complement of this number is this one. The 2's complement of this number is this one. And this is your answer. So 2's, this is the number. Um, this number is actually 12. So if I run this 110, 110, 1. So if I run this, we can check that what is the number. Answer is minus 11. Um, Actually, this number, when you are taking the 2's complement of this number, 2's complement of this number, so it is 110, 110, and 1 comes here. This one remains same. 110. Just a Okay, sorry. Actually, there is a things that I think I have done wrong. This is our original number. So we have to like when you are this is your 10 when you convert every digit, so you get this number, and in this number you have to add 1. So this value is actually when you convert that you have to take this one. I take this thing wrong. So this is actually 0. ये 0 है. This is actually 0. So this is your original number, that is the plus 10. You are taking the complement, or we can say that how this is our number that comes in the answer. I convert that 1 into the 1, all the 1 into the 0, and all the 0 into the 1. So this is the 1's complement. After that I add 1, and when I get the 2's complement, so 2's complement actually this one, this is 1, and this is also like this. Yes, this one. So this one is the 2's complement. So you can say that B, like this number is actually, if you see this number is actually plus 11. This number is actually plus 11. So when you have plus 11 and you take the 2's complement of this, then you will get this one. So this is actually your B, and this is negative 11. So in this way we get our answer. This is the negative number. Okay. So in this way, whatever the number you have, first you have to convert the every bit. After that, you have to take the 2's complement of that number. You will get a positive number. That positive number is your answer with negative sign. Okay. So I hope you got that. And in this way, you can find that when you are taking the 2's complement, or how negative numbers are stored in the memory, all that things, concept are something that you know. I hope that you got that. Okay. Thank you.